Today we will continue with the next classification after Dober-Reiner's triads law, that is Newlands law of octaves. We will start with Newlands law of octaves. John Alexander Rena Newland was popularly known as Newland, was a famous British chemist and also a musician. The scientist name is John Alexander Rena Newland. He used the concept of repetition of the musical note while classifying the elements. In 1866, he arranged totally 56 elements in the increasing order of their atomic masses. In 1866, he arranged totally 56 elements in the increasing order of their atomic masses. And he observed that every eighth element and first element are having similar properties. Then he stated this as Newland's law of octaves. The statement for the law is statement states that when the elements are arranged in the increasing order of their atomic masses, then every eighth element has similar properties with first element. This is the statement of Newland's law of octaves. The law states that when the elements are arranged in the increasing order of their atomic masses, then every eighth element has similar properties with the first element. It is compared with a musical note, that is sa, re, ga, ma, pa, da, ne, and again sa. See here, this is the, if we consider this as a first, second, third, fourth, fifth, sixth, seventh and eighth. This is the first note and this is the eighth note. So Newland compared this to musical note, that is first note and eighth note are similar. Now we discuss some of the octaves. First we write the elements in the increasing order of their atomic masses. So we start with hydrogen, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, potassium, calcium. Here we arranged the elements in the increasing order of their atomic masses. Now we consider the first column. It contains the elements hydrogen, fluorine and chlorine. See here, hydrogen is the first element and fluorine is the eighth element. See here, if we consider hydrogen as the first element, then 1, 2, 3, 4, 5, 6, 7 and 8. Here, hydrogen and fluorine are having similar properties. Similarly, if we consider fluorine as the first element, then eighth element is chlorine. That is first, second, third, fourth, fifth, sixth, seventh and eighth. According to Newland, these three are having similar properties. That is, the first element and the eighth element are having similar properties. Similarly, if we consider the second column, that is lithium, sodium and potassium. Lithium is the first element and sodium is the eighth element. First, second, third, fourth, fifth, sixth, seventh and eighth. Similarly, sodium, if we consider sodium as the first element, then potassium is the eighth element. That is 1, 2, 3, 4, 5, 6, 7 and 8. Here, lithium, sodium and potassium are having similar properties, and also here sodium and potassium are highly reactive elements. This is observed in other elements also. Beryllium and magnesium are having similar properties because beryllium is the first element and magnesium is the eighth element. If we consider magnesium as the first element, then calcium is the eighth element. That is first, second, third, fourth, fifth, sixth, seventh, eighth. Similarly, boron with aluminium, carbon with silicon, nitrogen with phosphorus and oxygen with sulfur. Here we not write the noble gases because they were not discovered at that time. Now we discuss some of the limitations of this Newlands law of octaves. In that, the first one is this law was applicable only up to the element calcium. Higher atomic mass elements are not follow this Newlands law of octaves. Next limitation is Newland assumed that only 56 elements existed in nature, but later several elements were discovered whose properties did not match with the Newland's law of octaves, and therefore he adjusted two elements in the single slot even though they are having the different properties, because to fit the elements in the table, that is, he adjusted two elements in the same slot to fit the elements in the table. This is the third limitation, and also he placed some unlike elements in the same slot. For example, he placed cobalt and nickel in the column of fluorine, chlorine and bromine, which are totally different properties with this fluorine, chlorine and bromine. And also he placed iron far away from cobalt and nickel, even though these three elements are having similar properties. This is the third limitation, and the last limitation is he ridiculed because he compared the chemistry with the music. Therefore, these points were not accepted by the other scientists, and this is about Newland's law of octaves.